Parallel connection of resistors. Here I have taken three resistors R1, R2, R3. One end of these three resistors connected at one common point, and the second end of three resistors connected at this common point. So this connection is said to be parallel connection. In the parallel connection of resistors, so current divides at each resistor. See here, there are three paths to flow of current. So this is the first one, second one, third path. So current divides at each resistor and the voltage remains constant in the parallel connection of resistor. Wherever you connect the voltmeter, the voltage remains constant here. Now let us find the current values I1, I2, I3 and total current value I. This is a parallel connection. In this parallel connection, one end of all the bulbs connected at this one common point and second end of all the bulbs are connected at this common point. Here positive terminal of the battery is connected this end and the negative terminal of the battery is connected this end. In this parallel connection of bulbs, current divides at each bulb or resistor and voltage remains constant. Let us prove that voltage remains constant in the parallel connection of resistor. Here the positive terminal of the voltmeter is connected at this end of this resistor and the negative terminal of the voltmeter is connected at the other end of this resistor. Now I am going to switch on the battery eliminator and let us observe the reading of voltmeter. Observe here 2 volts. The voltage between two ends of the first resistor, first bulb is 2 volts. Now let us connect the voltmeter between two ends of the second bulb and again let us check the voltage. Observe here, voltmeter is connected between the two ends of the second resistor, that is second bulb. Now let us switch on the battery eliminator and observe the reading of the voltmeter. See, again voltage is 2 volts. The voltage between two ends of the second bulb is 2 volts. In the case of first bulb also 2 volts. In the case of second bulb also 2 volts. Now let us connect the voltmeter between the two ends of the third bulb. Observe here, the voltmeter is connected between the two ends of the third bulb. Now let us switch on the battery eliminator and observe the voltmeter reading. In this case also the voltage is 2 volts. In the case of first bulb, in the case of second bulb and in the case of third bulb, so voltage is 2 volts. That means voltage remains constant in the parallel connection of resistors. In the parallel connection of resistors, current divides at each resistor. Let us find how much current is flowing through each path. To measure the current, we use the ammeter. Always we connect the ammeter in series in the circuit. Here, see here, positive terminal of the ammeter is connected at this end of the bulb here, and the see here, other negative terminal of the ammeter is connected at this end. Now let us switch on the battery eliminator and observe the reading of the ammeter. See here how much current is flowing. So it is fifth line is indicating least count is 0.05. That means 0.25 amperes current is flowing through this path, through this bulb, through this resistor. 0.25 amperes current is flowing through this bulb. Let us make it note. See here, potential difference across each resistor is 2 volts and through first bulb the I1 current is 0.25 amperes. Now let us measure the current through the second bulb. How much is current is flowing through the second resistor, second bulb. To measure the current through this bulb, here the positive terminal of the ammeter is connected at this end and the negative terminal of the ammeter is connected to this end. And let us switch on the battery eliminator. Observe how much is current passing through the second bulb. So this is a sixth line is indicating, sixth line. See here, least count is 0.05. 6 into 0.05. That is 0.3 amperes current. 0.3 amperes current is flowing through this resistor. 0.3 amperes current is flowing through this resistor. Through the second resistor, 0.3 amperes current is flowing. Now let us find the how much current is flowing through this third resistor. To measure the current flowing through this current resistor, see the positive terminal of the ammeter is connected this end of the bulb and the negative terminal of the ammeter is connected at this end. Now I am going to switch on. Observe the current value. Again 0.25. Fifth line is indicating 5 into least count is 0.05. 5 into 0.05. So that is 0.25. Through this bulb, the flow of current is 0.25 amperes. Through this first bulb, current is 0.25 amperes. Through this second bulb, the current value is 0.3 amperes. Through this third bulb, the flow of current is 0.25 amperes. Through the third resistor, the current value is 0.25 amperes. Here, sum of individual currents drawn by each bulb is I1 plus I2 plus I3. So 0.25 amperes plus 0.3 plus 0.25. So total 0.80 amperes. Now let us find the total current drawn by the battery. It is I value in the circuit. To measure the total current flowing in the circuit, the positive terminal of the ammeter is connected at this common point and the negative terminal of the ammeter is connected with the negative terminal of the battery. Now I am going to switch on. Observe the current value here. Here 16th line is indicating 16 into 0.05. That means 0.80 amperes current. The total current is 0.80 amperes in this parallel connection of bulbs. Total current drawn by the battery is 0.80 amperes. From this activity, we can conclude that sum of individual current drawn by each bulb I1 plus I2 plus I3, so that is 0.80 amperes, is equals to the total current drawn by the battery I, that is 0.80 amperes. Like this, in the parallel connection of resistor, voltage remains constant, that is 2 volts, and current divides at each resistor, so that current, sum of individual current drawn by each bulb is equals to the total current drawn by the battery.